We are focusing on the business management and operation block, and specifically in the multi-DSS area of the architecture. We look into the Fmeca tool. In the previous version of the Fmeca application, we can define failure modes, causes and effects and assets, and then combine them in an Fmeca analysis table. Each combination has drop-downs for occurrence severity and detection levels. The results are in table form and in heat matrices. In the new version, we start with a tutorial explaining the concepts of the analysis, the hierarchical approach for the application and its mathematical background. There are guidelines on how to run the application. First, we define the part types in the machines and their failure cause data, such as failure rates or MTBF. The next step is to create the system hierarchy as is shown in the tree formation. Within the hierarchy, we define the failure modes, failure effects, as well as the severity, occurrence, and detection levels. Each level in the tree is connected with its branches, reaching out to the root level. Connecting the subsystems, we get the Fmeca results in a pop-up as a combination of tabular and heat matrix representations. Staying in the multi-DSS area of the architecture, we are now focusing on the environmental assessment tool. The tool evaluates process scenarios from an environmental perspective. Starting with environmental impact data, we see the material impact factors used in the tool for the manufacturing and recycling of different materials. Going to transport, we see the impact for different modes, and in the energy section, the impact for different countries. Factors are used to estimate impact and benefits of life extension options. In the components sections, we define the material composition of the machine components. This is central to determining the environmental impact of manufacturing components, and we can also select which components are present in the machine. We select scenarios to compare, and we get the results for a set of impact categories. Results are also expressed per phase of life cycle, revealing where the key contribution to the impact occurs. Staying in the multi-DSS area, we conclude to the multi-DSS, demonstrating here the complex event processing functionality. We can build complex rules with the graphical tool, put in conditions and thresholds to handle multiple events that may occur. The decision tree is formed to describe the different scenarios and options. We can route it to different paths by setting logical controllers or mathematical functions. In this development phase, there is the possibility to test the system by changing the conditions and thresholds in the decision tree and observe the results of the different scenarios. Each time the conditions activate a certain path, it becomes green in the graph, status true 1. When it's deactivated, it becomes red, status false 0. We can also send notifications to the involved actors in each scenario. Thank you for your attention.